So my students have said to me to make my videos more interesting, they wanted me to wear pyjamas. So here we go. So here I am in the pyjamas. Okay, so let's talk about chemistry though, not about me. Okay, so Gibbs 3 energy exam style question. We're going to go through every single type of exam style question you're going to come across in Gibbs 3 energy parts. So often my students say these are the most useful ones that I produced. So here we go. So we've got methanol can be made by the reaction of carbon monoxide with hydrogen. Calculate the maximum temperature. Again, this maximum doesn't matter. You still do it in the same method regardless of whether it says maximum or minimum. You're given an equation, you're given the delta H, and you're given entropy values. Entropy values are in joules, that's the most important thing, and this is in kilojoules. So you need to convert that into kilojoules when you finish. Let's move this to the side. Okay, and then let's go through. So first of all, in these questions, the first thing you've got to do is work out your delta S. That's your products minus your reactants. So most important thing, remember there's a balanced chemical equation there, so 2 times the number for hydrogen and 1 times the number for the other two. So if we put those in, that's our hydrogen. This is our product minus our reactants. Okay, we get minus 222. Okay, still in joules at this moment. We're going to convert it into kilojoules when we do our maximum temperature calculation. Now, if we go to the maximum temperature calculation here, we've taken our minus 222, which we calculated before. I'm going to put it into delta H over delta S. So if you're ever calculating the temperature at which it is feasible, that's because remember we said in the first video, you assume to be feasible delta G is 0. So you rearrange the equation with delta G equals 0 to equals T. And if you rearrange it, it's delta H divided by delta S. So if that's the case, both the units must be in kilojoules. Okay, so I always go for kilojoules and not joules. Okay, but it doesn't matter because it's a ratio. But I always go for kilojoules. So therefore, you've got that. Notice I have changed the 222 into kilojoules. So I divided by 1,000 to get from there to there. That then, remember we're doing a maximum temp, and that then gives you your Kelvin. Now, really important, the question to complicate it, and we will have one later on that has degrees Celsius, okay, can ask you for degrees Celsius or Kelvin. All you do is minus 273, okay, so minus 273 from that to get your degrees Celsius. So bear in mind, look at the question, okay. So, should we move on to the next one? Right, super. So the next one is to do the hard process. It's maximum temperature again. Why don't you stop, do it yourself. Don't let me do it, okay? Do it yourself. It's minus 92 kilojoules per mole. We've got another thing. It's exactly the same style of question. So just see you do it again, okay? I'm going to pause for a little bit of uncomfortableness just so you can get your finger on that button and stop the video and then do the question, okay? And it is... And let's carry on. So your products minus reactants and the sum of each, okay? And we put that in there. Again, we're using our balancing of the equation, the 2 and the 3. There's your 2 and your 3 placed in there, reactants and products. Okay, minus 200 is the actual answer. Remember, we're going to change that to kilojoules. If we then do it like this, let's just put that back up again. Okay, and we've got minus 200. The minus 200 is going to have to be changed into kilojoules, so we divide by 1,000. Okay, and the numbers will go in shortly. Okay, and there you go. Minus 9 divided by that, which gives you a temperature of 460 Kelvin or 187 degrees Celsius. Okay, so we've got 2 versions here of maximum temperature. Do you know if we've done maximum? Why don't we do minimum? So we're going to do another one on minimum temperature, but this time we're going to include Hess's cycles. So this is one of the more complicated ones. Okay, so if you watched Hess's cycle before, please go ahead. If you don't know how to do Hess's cycle, it might be good to go into module 3. There's some videos on Hess's cycle there. And we're going to do Hess's cycle in terms of enthalpy changes of formation. So minimum temperature is in degrees Celsius. Okay, so we're just going for that normal calculation we did in the last 2 examples. Okay, and then we've got our entropy values. Now, let's put that to the side. Let's just get on with doing our entropy values. So products minus reactants. Products minus reactants. You got the N2O here, which is your 220, and your 88 times 2, because you've got 2 moles of the water, minus the 151, which is the ammonium nitrate. We have then got this number here. Now, that number there is down, and now we're going to work out our delta H, because if you notice, but we don't have a delta H value, it's not been given. Because it's not been given, that means we have to calculate it, and that's why we're given these lovely values over here, these delta FHs. Now, delta FHs are enthalpy changes of formation. So that's enthalpy changes of formation. And so we're going to need to do a Hess cycle about enthalpy changes of formation. So first of all, you need the definition. Definition is when you have 1 mole of a substance that is made from its constituent elements. The constituent elements of these are nitrogen, hydrogen, and oxygen. Okay, I've balanced them out already, but you don't really need to do that in the exam. Okay, first of all, enthalpy change of formation of ammonium nitrate. Ammonium nitrate is down here. Okay, there's your ammonium nitrate, and there's your value for the enthalpy change of formation. Okay, so the enthalpy change of formation is this value here, going from here to here. Next one, and that's delta 1H, by the way. Next one is delta 2H, okay, and that is formation of N2O and H2O. So formation of H2O and N2O is there, and the numbers are there. So I've now got a cycle, and I've done the green arrows in the same colour, because those 2 arrows are going in the same direction, so a bit like a circle here. And you follow them, they're going in the same direction, okay, which means I can add them together to equal that one. So 2 equals R plus 1, okay, so 2 green ones. And then you just rearrange it, minus the 1 away from the 2. So the 1 away from the 2 equals the R. Now let's get rid of the one we don't need, and we've just got that. Okay, from that point, we then have to work out what 2 is and what 1 is. Okay, so 1 is minus 424. So we look down here, we can see minus 424. Okay, and that's the formation of ammonium nitrate. Then we've got 2 times minus 241. Minus 241 is the water. Okay, and then we've got the 82 for the N2O, and that adds up to minus 400. And all we do then is plug the 2 numbers into here. Okay. So we're going to keep those there and then plug the 2 numbers in. So we plug the 2 numbers in and we get 24 kilojoules per mole. We then go back to this, which is T delta H over delta S. Remember, we must keep it in kilojoules here. Okay, so there's your kilojoules. We've converted this number down here, the delta S, into kilojoules. Then that gets 53.9 Kelvin, or minus 219 degrees Celsius. Okay, so yeah, and do not worry about the numbers and things like that, any numbers that come out. They changed these numbers to try and make them nice in the exam, and I've changed them to make them nice as well, okay? But just remember that process. If you want to get an A star, which all these videos are designed to get you an A star, you just have to look at these different, these kind of examples, because they're the ones that will push you, okay? So our final part is one of the more difficult questions as well, especially if you're not a mathematician. So what they decided to do is make it difficult by adding some maths in there, and for us people who aren't mathematicians like me, okay, that makes it harder, okay? So delta G versus temperature. So they plotted the delta G equation in one of the exams as delta G equals minus delta S T plus delta H. That's a rearrangement of the delta G equation. So, and it's a rearrangement in this fashion: y equals mx plus c. Now, if you're not a mathematician, this might not be natural to you, but it's really worth knowing that you can rearrange that to equal exactly y equals mx plus c. And if you're actually a mathematician, you can do it straight away without any help. You don't even need to rearrange it. You can see it's a y equals mx plus c equation. But if you're not a mathematician, it's really important that I point it out. Okay, so the delta G equation can be put in this, right? And that means the m is your gradient. So your gradient is minus delta S. The x-axis is t, and your delta G is your y, and then your intercept is c, okay, and delta H. So that basically means this is my delta H, okay, and I'll write this on here, okay. So if I want to do my intercept here, okay, that's delta H, okay. If I want to know my gradient, so I'm going to do a very rough gradient here, woo, like this, and I do my difference in y over my difference in x, okay. your dy, difference in y over difference in x, is going to equal your minus delta s. Okay, so that means you can get your delta s by that, by just converting it, times it by -1. Okay, and then it's some really important things, because you've got a delta h, we've got our delta s from our gradient, okay, and we've also got this line here. Okay, so if you look at this crossing of the line here, not immediately obvious to everybody else, okay, but that is crossing the 0 point. So this bit here is 0, okay? That means delta G is becoming 0, which means the reaction is becoming not feasible. Okay, so that means the temperature at which this reaction is feasible is on this temperature line, because remember this is temperature versus delta G. So right here, right as we cross here, is going to be, let's do a little arrow here. This is the temperature, and this is the temperature at which it is feasible. Okay, the temperature at which it is feasible. Okay, so you can get a lot of information from this graph. Okay, your delta H, you can get it because it's the intercept. Okay. And let's put that back up there again. So there's your intercept. Okay, and there's your t, which is your x-axis. Your minus delta s, which is your gradient, which I've just drawn on here roughly. And your delta g is going up here. Your delta g, remember, gets positive. That means it's not feasible anymore. And the temperature at which it becomes feasible, unfeasible, or feasible in that direction, okay, is when it crosses this axis here. And so you can know exactly when the temperature at which the reaction is feasible from this graph. Now, that's the end of our delta G exam style questions video. Okay, again, as I always say, please share these videos. Thank you so much for liking, subscribing, all of that stuff. Okay, I really hope it helps. And if you've got any suggestions of what you want me to wear, as long as it's not dodgy, okay, please let me know. Okay, and in the next one, I will be wearing a Christmas jumper, just for those people who are feeling festive. Enjoy.